4 kilogram mass. And we also consider the direction of the acceleration, which will be given by 4 g, which is the force, minus the attention, being equals to 4, being equals to 4F. So that if I substitute the value of g, we'll have 4 times 9.8 minus t equals to 4 equals to 4F. So 4 times 9.8, that has given us 39.2 minus t equals to 4A. I want to make an equation like that by making t and 4A on one side. So meaning that this one will go that side. That someone can have 4A plus t. 4A plus t equals to 39.2. Since the question wants the value of the acceleration and the tension, I'm going to solve these two equations. Solving the two equations, I may just look at it by saying that we can go ahead and subtract, because if I look at the tension and the tension, we can easily get them by subtraction. So if I come and say maybe equation 1 minus equation 2, I'm going to arrange this. Say t minus 5a being equal to 32.64. Then if I arrange this one also, that is with t, that is my plus 4a equals to 39.2. Subtract this one here, will have to go, meaning that if I subtract t minus t, you will have this, which will be giving us negative 9a equals to 32.64 minus 39.2. This one has given us negative 6.52. Then you can get a by dividing by negative 9. By negative 9. Our acceleration, if I divide by negative 9, is 0.7. So 89.
This is is 0.7289 meters per second. Meters per second squared. But here the question was saying that we should investigate the acceleration of the system and the time taken for the hanging mass Q to reach the ground. Remember, for the hanging mass Q to reach the ground, it was initially at a point 2 meters above the ground. Which means if I consider that statement, they say initially means that it's the velocity, the initial velocity is 0, meaning that the body is no longer at rest. It is moving. So I'm going to look at this. I'm going to put in this part. I'm going to say add. You can say at s equal to 2 meters, because it is initial. Our u is going to be 0 meters per second. So meaning that at this point we are going to look for the value of time. Still, we are going to recall our series equations of motion, where we say that in the first equation we always have u plus at. The second equation we are having s as ut plus half at squared, and in the third equation we have v squared equals to u squared plus 2a plus 2as. Now we have to come up with an appropriate equation we can use here to come up with the value of the time. When you look at in the first equation, you realize that we don't have the distance, meaning that this one here without error pass. We are only seeing the initial velocity and we are seeing the acceleration. The second one, we can see that we have the distance, the initial acceleration is there, and we are looking for the time, but we have the acceleration which is 0.789. So this one can work for us. But in the last one, we don't have the final. We have the distance, we have this, and we have this, but we are looking for time. Meaning that the most appropriate equation we can use here is the second equation of motion. That will be the S equals U T plus half T squared. So I'm going to say using S equals UT plus half AT squared. So I substitute for my S, which is 2 meters. Our U is 0 times the T plus half times our acceleration. We are using what we have got, that is 0.7289 with T squared. So this one here will go. We'll have only 0. We'll have 2 equals to, when you look at this value divided by 2, it's the same as 0.36. You can say 364 T squared. 0.36 T squared. By divide by that, you'll have your 2 being given to 0.364. That if I have the 2 divided by that, you get 5.48. We can say 879. So our T is going to be as a result of getting the square root of this. The square root of that is 2.3426 seconds. That one will act as our time. But also they are saying that we should do the time from the hanging mass Q and the distance, or the distance of the mass P. The distance the mass P move up the incline plane. When we go back to our scenario, they are saying that the system is released from rest with the string curve. Which means for this P to move upward, we are going to get their distance. The distance will first of all be opposed by this one here. Supposing this one here is to break, what will happen here is only one. This P is going to move backward. That may cause some kind of deceleration. Which means what I'm going to consider is I am first of all going to consider the velocity of what? The velocity of P. The velocity of P is going to come from what we have so far. That is from the acceleration and the time. So let us first have the velocity of P here. The velocity of the mass P. So from our velocity of the mass P, is going to, you can use this, which is the appropriate one. That is V equals to 80. Since mass P is not at rest, meaning this one here will be 0 because it is in motion. So we are going to have the V of P. I'm going to substitute this one here with 0. Then our acceleration, still I'm going to use the 0.7289. Then you multiply by the orbital time. That is the 2.3426. So this velocity 0.7 28, 0.7289 times 2.3436. 426, not 36. 226. So you have 1.7, 1.7075 meters per second. That is the velocity. So now we can get the distance of P. The distance of P, we'll have to first look at the P itself. The P from the expression, we add it as the towards this. So we add the T minus all of this. This one here was what? 32.64 equals to 5A. That, like I said before, that this one here may cause, in fact, in case this string is to get broken, this one will have to go back. So I have to find the deceleration of P. At this deceleration means that we will not have any tension. Every forces will have to move behind. This one here will not be there. So we are going to say at T equals 0 Newton. That's when I don't have the tension. So you have the negative 32.64, which will be given by 5. Yeah? That F prime is the same as the deceleration. So you have divided by 5. So that's our deceleration here. If I divide that 32, divide by 5, 32.64, divide by 5. This is negative 6.528 meters per second squared. So now we can now go ahead and get the distance. The distance is I'm going to, because I have the velocity, I'm not going to use S, I'm going to use V squared equals to U squared plus 2AS. I have the acceleration, and also you have
the final velocity V. So our final velocity V is the same as 1.7. It was 1.7075, but this one here is a square. This one here,
this body is moving. So this is 2 into our acceleration, that was negative 6.5 to 8 times
our S. So we realize that we are going to have 1.7075, which is a square. Because we are having this. In fact, this one here is supposed to be a negative, because it's moving backward. So it being a negative, it will, if this one multiply,
meaning that we are going to multiply this one times 2 into, because the negative has multiplied inside, 2 into 6.528. Then we obtain our distance. Divide both sides. So we'll have our 1.17, 1.7075 squared divided by 2 into 6.5 6.258 6.258 squared. So this is 0.2223 meters. But this is not the only distance P has to move on, because they have told us here that that if Q is initially at 2 meters above the ground, that is for Q. This one here, if it is 2 meters above the ground, which means we should expect now this one here to be above of it. This one here should be up. So which means we are going to get the distance of P. I'm going to get the 2 meters, which was already given by Q, and then I add the obtained distance. That is this. So you realize that the distance of P is going to be 2.2 2.22 meters. That's if I get the sum of that. So in the second paragraph, they have told us that at the top, we are now answering part B. They're saying that we want to investigate the single force that could replace the four forces. But they have told us that the forces given was the forces that was acting on the sides of on the sides of a rectangle. But the sides of the rectangle was not given. But we are given an expression that could be the sides of the rectangle. We are told that AB is equal to 2AD. Remember, if it is the side of a rectangle, we realize that it is always that one side, it is like 2 times the what? 2 times the other. That's why I'm given AB to be equals to 2AD. If your AD is Y, which means AB
is equal to what? AB is equal to 2y. That was the confusing part of this. I'm going to
expression here. I'm going to say that if we are having AB, like we have said in the scenario, that if our AB is equal to 2 AD. So if I say let AD, if our AD is equal, let us say it is equal to Y, meaning that our AB will be given by 2y, because AB is 2 times AD. So let us try to put this into a simple diagram. I am going to allocate this A, B, C, A, B, C, D. Our AB is the 2y. That's the distance from here up to here. Then our AD from here up to here is the same as the y up to here. So we are going to also put the forces. They are saying 4 Newton acting on the side AB should be represented by an arrow to show the direction. CB being given 5 Newtons. That is the force acting this side, given 5 Newtons. 9 Newtons is for AD. From A to D, they have said is 9 Newtons. Then AC, that is the A moving to the side of C. Here we have been given 6.2 Newton. That is at that point. So it means we should be able to know these angles here, and even this one here at the same, that one there at the same time, before we get the single force that may be acting on that rectangle.
If you look at this, I can say that our theta, because when you look at what we are given,
The sides of this rectangle. I know this part or this part, which is the same as a y, and I know this part from this part, which is the same as 2y. So if this is our angle, we realize that we are going to have the opposite and the adjacent. So that one will be calling for the tan of the angle. That is given by opposite. You can say the opposite is AD divided by the adjacent, which is AB. So that the angle be taken by the tan half of our AD, which was y, divided by AB, which is the 2y. So you realize that if I cancel the y, we are only going to remain 1 over, will only remain 1 over 2. That will give us the angle. So 1 over 2, the tan inverse, you can say the tan inverse of 0.5. That is the same as 26.6 degrees here. So that 26.6 degrees will now help us
in resolving this rectangle. So we are going to resolving. I'm not going to put vertically or horizontally because we're going to have, you can say, resolve
axis, and also I resolve on the y axis. We are going to get Rx and Ry at once. I'm going to be dealing with each and every forces. Like if I look at the force, which is 4 Newton, you realize that this force, which is 4 Newton, it is acting on X, meaning that if acting on X, we will not be having the vertical component. It is only having the horizontal component, and it being a direct force, we are going to write it the way it is. Meaning that on when I'm resolving this one here on X, it's going to be 4. Since it's not acting on Y,
this is going to be 0. And it is a positive because
positive side of the X axis, or on the positive side of the horizontal axis. We go to another one. Another one, it is the force, which is the 5 Newton. This force 5 Newton, if I try to draw my Cartesian plane, this force 5 Newtons is acting on the Y axis, as you can see for this one here. It is acting on the Y axis, and when you look at its direction, you realize that its direction is downward. So being downward means that it is acting on the negative side of Y, meaning that we don't have also its horizontal component. So this one here will be given as 0 for X and negative 5 for Y. And then we go to another one, which is still a direct force. That is another force of 9 Newtons. Even this 9 Newtons is acting on the Y axis, but upward, meaning that if it is acting upward, it is a positive force. And it being a positive force, it will also not have the horizontal component. So it will also be given as 0 for X, which is a horizontal, and a positive 9 for Y, which is a vertical. And then the last one becomes the force that is acting as an indirect force. So this force here needs to be resolved, and in resolving, we are going to resolve it basing on or using our angle, which we have got as 26.60 degrees. Always we say that if I have a force, let us say we are having a force acting on the xy plane. This is the force already. This force is acting upwards. Let me say it is a P Newtons acting at a certain angle. So this force will have to resolve it both horizontally and vertically. And because it is acting upward, it is assumed that every force is starting from this point as the origin, meaning that they are all supposed to go and make a meeting point at that point. Meaning we have to move that side and this. So this one will act as the P cos of the angle, and this one here will act as the P sine of the angle. And the next time someone may also find another force that may also be acting in another way. This. So you realize that when you look at this force, let me assume that it is acting this side. I'm going to give it a side of R Newton. Even this one still, I have to resolve it with the horizontal. Resolving it with the horizontal means that this one here, it is now acting because it's coming from upwards. This one will act as the starting point, meaning it has not to move like this. It has to move like this until they come and meet at that end. So I'm going to look at this moving downwards and this one moving upwards. It will be having the negative vertical and the positive horizontal. Bringing now into this one here, you realize that this one here will be having its point of action here, and then we are going to meet at that point. If I try to follow the direction, you realize that it is going to move on the positive side, that is for x, and on the positive side, that is for y. So I'm going to take on x, basing on that, you're going to have 6 root 2 cos of our angle, which is 26.6 degrees. And then on the side of the vertical, we'll also have 6 root 2 sine of our angle, which is 26.60 degrees. So that is what we are going to be having. So now we can get the Rx and the Ry all together. Rx and the Ry, I'm starting with Rx, that is 4, because all these ones are 0, plus 6 root 2 cos of 26.6. So on Rx we are having 11.5872. Then on the vertical we'll have negative 5 plus 9 plus 6 root 2 sine of 26.6. So this one is the same as 7.7994. Then you can go and get now the magnitude of the force, or the magnitude of the force acting as the resultant, where we said the F for this case is always given by the square of the resultant at x plus the square of the resultant at y. So you'll be having the R magnitude, which will be given by 11.5872 squared plus 7.7994 squared. So we also get this one here at once. You have the square of 11.5872 squared plus this is 7.7994 squared. Then if I get the square root of the answer, you find that we are having 13.96. You can say 76 newtons. These forces should always be given for decimal place. And whenever they have asked us for the single force, this single force should also be having the direction of where it is moving, because I cannot just come and place it on all these forces when I don't know where it is supposed to face, either a negative or a positive. Meaning this one here will be calling for the direction of the resultant force. Where in our direction, I will also be looking at what we are having, because when I'm inputting this, I'm not going to put them basing on the sign. So if I have the direction of the resultant one, direction